Good afternoon, good morning, good evening, wherever you are, welcome. I'm Chris Short, Principal Technical Marketing Manager at Red Hat. I am joined today by the one and only Scott McCarty, also known as Father Linux on most social media and I think even GitHub. So Scott, you hit me with a flurry of ideas a couple of weeks ago, or I think like 10 days ago. And also, congratulations, you have a baby due soon. So we had to squeeze this one in last second. And so we were coordinating over the weekend. I was building social media tweets and stuff yesterday, or images for tweets yesterday. It was fun. So I'm glad you're here. You are going to hack away on Podman 2.0's API, and you're going to show me all the magical things, right?
Yep, I'm going to show you the magic.
All the magic. You're a little
magic.
You're a little quiet, by the way.
Am I a little quiet? Oh, hold on. Let me see. I can probably fix that.
Yeah, I feel like you can. You
I've
can
got
do
the
it.
Power.
You have the power. Also, you were loud like 5 seconds ago, but whatever.
Was I? Okay.
You weren't loud, but I could hear everything. Anyways, so yeah, Scott is figuring that out. But Podman is a drop-in, hopefully, replacement for Docker client. It's daemonless. It is a beautiful thing if you want to just run a container. It has a lot of great bits built into it. I just learned the other day that you can actually use a command to generate a systemd file to run your command or run your pods at boot, which I thought was awesome. So I don't necessarily need a full-blown container orchestration system to run a group of containers. I can just have a pod off and running with a handful of containers in it right there with the unit file. So what do you got for us today, buddy?
Well, can you hear me now? Let's check that first.
Yes,
all right,
Verizon,
we're back. We're back in action. Yeah. So yeah, the funny part about Podman is you can do all kinds of hilarious things. Like you can use systemd unit files as root. You can actually even use them rootless, which I will actually show a little bit of, which is actually pretty funny. A lot of people don't realize that systemd has a facility to there's this -- user command, and you can actually like set up unit files and things to fire up like when you log in or when you connect to a socket as a regular user. And so like we can do rootless. We can actually do rootless even with systemd. So we jokingly say you only need one big fat daemon. You only just need one.
Uno.
Solo uno. Yeah, you just need one. And every Linux system on the planet basically has that one. So we're like, we may as well just reuse that one instead of having a whole bunch of them.
Right.
So I was going to lay a little groundwork so that people understand before we start hacking on the command line, like how all these parts fit together. Because I use some very specific nomenclature when I talk that I'm like a trailblazer in this, because like people interchange a bunch of words and I try to be very like, and it confuses all of us. So I try to be very specific. So I could probably dig into that for a few minutes and then start hacking, then start digging into our API.
Yeah, let's do it.
Yeah, all right, that's cool. Let me share my screen. I think that's probably the best thing to do here.
Yeah.
Let's see. Oh, did I lose you?
No,
nope, I didn't.
I'm still here.
I just realized I shut that other window. Hold on. There was a Zoom thing up because I'm in Linux, so it fires it up in a strange way.
Did you log in Xworks, or are you on Fedora?
No, I'm in Rel 8 because I'm like a hardcore.
Well, then yes, you probably are in Xwork.
Share this screen.
Can you share screen?
I believe I can. Let's try this.
Ta-da. Does that look like I'm seeing me. I'm seeing Slack. I'm seeing all kinds of fun things.
Yeah, let's get
there we go. Some slides.
Yeah, let's get to a screen that I want to share.
There. Yeah.
All right. So I mean, anybody that knows me.
Fun.
What was that?
Screen sharing is fun.
It is fun. So this is from a lab that I do all over the place. I've done it a bazillion times and I love it. But like, there's like, you kind of at least need to understand at this level that like what I call a container engine is the thing that goes and talks to the runtime, which is runc most of the time. There's really no name. Like we kind of have, this is the piece where it gets confusing, right? Like like I argue that like the job of the container engine is to provide an API to a human being typically, or to another robot. So
Mhm.
like in the case of Podman, this is for humans, this is for robots, this is for the kubelet basically to talk to it.
Right.
And then if you look at like Docker, this is for humans, and then this is kind of for robots, and it's kind of like together, I guess, if you will. Um, but yeah, like you can kind of compare Cryo and Containerd pretty comparatively. You can
Mhm.
kind of compare Dockerd and Podman pretty comparatively. But at the end of the day, like the main thing is that there's an API endpoint for like humans to get into this thing and then run some commands. And then below the covers, runc is the thing that basically talks to the Linux kernel and basically does all the heavy lifting. And so like you'll see that like generally we share this among all of them. And so what I'm going to show is that like you can actually run this thing. Well, I'm going to show you a whole bunch of things, but like you can run this thing as root, which is how Docker works, or you can run it as a regular user, and that's what
Mhm.
we refer to as rootless. And then I'm going to show you how we can actually now with Podman we can actually use what's called a socket activated daemon. It's a socket activated service is what I should call it, to basically fire off Podman, and then basically Podman gets out of the picture, and then runc comes into the picture, fires up the container, and then it gets out of the picture, and then basically there's something called conmon, container
Nice.
manager in the
Yeah.
Podman world that basically sits there and like monitors the input output, the terminal input output of the container, and it kind of lives, and it's what kind of communicates. It's what conmon is, what basically what people get confused about. They go, oh, well, there's a daemon to keep track of it, and it has a database, and it knows what containers are running or what aren't. But that's not actually true. Like it's just data on a disk, right? Like if you look at Podman, it's varlib containers. If you look at Docker, it's like varlib Docker. And so like it's just saving stuff in files on a file system, and that's all it does. And it knows what's going on. It just happens to be that the Docker daemon is running all the time, and then it shuts down. It never really shuts down. Whereas Podman, it just automatically shuts down and then only fires back up once you run the command again. And so what we're doing is we're having systemd socket activate it instead, and then you can basically do all kinds of hilarious things. Yeah, I didn't come up with a drawing for that, and I should have.
No, that would be great. What does hilarious things look like in pictures?
Yeah, exactly. Like so this is like this one probably does a decent job, right? So like in this scenario, like I show like here's what OpenShift, which is basically Kubernetes. You can think of this as the API.
Can you like blow that up
Nope.
somehow so other people can read it? Because I can't even read it. Sorry.
No worries. How about that? Is that better?
That's better.
Yeah, I wonder if I could even go bigger than that. I don't know how to do that.
I don't know if you can plus up in a slide.
Let's try. Nope, doesn't seem
Nope.
like you can.
Okay. Oh boy.
Oh, it did work.
It kind of weird. All right.
Nope, it didn't like that.
Okay.
Google does not like that.
Okay. All right.
That
was fun.
No,
yeah, I think you're fine.
That definitely locked up my computer. That was awesome.
That was good. Good job.
So like, let's just walk through. So like, can you hear me now?
Yeah, you're good. Go ahead.
Okay. So like a Linux system boots, right? When it first boots, this piece comes online, right? The Linux kernel boots up. Think of it as a special program. Systemd is the first program that runs after the Linux kernel. It fires this up. And you'd think with something like Docker or Cryo, even they're a daemon, this container engine's the next thing that gets fired up by systemd. So you could think of this as a user process, right? And then at the same time, if you're running Kubernetes or OpenShift, you have the kubelet, which you can think of as this. We call it the OpenShift node. But really think of it as a piece of software that is sitting on the Linux box that basically goes and talks to the container engine, right? So this is kind of how, when you like schedule something with Kubernetes, for example, it goes and it talks to the kubelet, which then talks to the container engine, which talks to the container runtime, which then talks to the kernel to go fire up a containerized process, which is these things on the right here. Nice. But when you're a human, you could just replace this orchestration node with a human being, right?
Yeah.
And instead of talking directly to the container engine, what we do is we talk to systemd. We talk to a socket. Systemd notices the socket, goes, oh, they're trying to talk to that socket. Let me go fire up this container engine. Basically makes this communication between these two.
Interesting.
And then shuts back down.
Okay.
And so that's kind of how it works with this systemd socket activated Podman.
Nice.
But yeah, I'll eventually come up with a drawing that shows that better.
I think it's more of an animation.
This is a hacker
probably.
session, though, so let's just dig in.
Yeah, let's Let's show me some stuff.
Exactly. So, what is happening? Do we have?
I've got a menu or terminal, I should say. Sorry, menu. Not sure where that came from.
Yeah, let's see if this is. Oh, there we go. No, it's blinking, but it's not doing anything.
Oh boy.
Let's see.
Worky.
Yeah, it's weird.
Huh.
My CPU's not going crazy here or anything.
It's not doing anything.
It's definitely. Hold on 1 second. Let me try to get over to here. Let me get to here and then try to see what's going on with my system here. What do we have? Zoom is kicking my butt.
Yeah, probably.
KSMD is kicking my butt too a little bit. Yeah. Let me unshare and shut a bunch of windows.
Good idea.
Let's try to kill some stuff.
Yeah, kill some crummy things.
All this stuff. Exactly. Chrome, you are getting crushed out. Leave.
Watch as the garbage collection process kicks on your machine when you close Chrome and let's kicks you off Zoom somehow.
And then we're gonna close this one. I think we're seeing improvements.
Okay, cool.
There we go. Let's shut this one. We have one more, and then I think we're good to go.
Are these? Okay, you have 5 Chrome windows open?
Yeah, I'm I'm beyond a power user.
Yeah, like I feel like I'm in the same boat sometimes.
All right, I basically abuse. Still nothing though here. What's going on? This could be something else, huh?
Did you lose the connection?
Yeah, let's see if sometimes this will do it. There we go. Usually that'll do it if we need to. There we go. Look at that.
All right. Now we're cooking with gas.
Now we're going to cook with gas. And, sadly, I tested this. So let's look at the system, right? So like this is a Fedora rawhide system, right? And so what we're doing here is we're basically, we got system D is the first process that gets fired up, blah, blah, blah. There's all the things you'd see normally at D, ABRTD, audit D, you see I have actually a container running. This is one that I must have had running. Cron D's running. This is my SSHD, and then this is my bash, and this is my PS tree. So this is where I'm at. This is what a normal system looks like. There's nothing magical here, but you'll notice that there's no Docker daemon running. Like if you look at this, there's no Docker daemon running. But I'm going to do something funny. I'm going to run a Docker command and be like, oh, look at that. That's kind of cool. There's like some container running, which is probably this one. Actually, even funnier than that. Let's do a Docker kill on that. Actually, you can't do -A because I'm so used to. Yeah. Let's see what happens if we do that.
Okay.
That should work. That's pretty funny actually. Now let's do another PS tree. So and then I'll show you behind the covers what's happening here. Notice the conmon is gone.
Yeah, much shorter tree. Yeah.
There's nothing running. There's no daemon running. You'll see this actually. The funny part is you probably see this because systemd fired it up for a second. It does like a 5-second thing where it fires it up whenever something talks to the socket. So if you do like a ps-ef, you'll see, if you like grep for podman, you'll see it for a little while. But oops, I guess you got to use grep. So you'll see, oh, there it is. So systemd or podman is fired up for a second there, but that's because basically systemd told it to go fire up for a little while. So let's dig in deeper. So like, let's go like normally what would happen is like Docker works by talking to a socket, right? Like it normally talks to /run, at least in a Red Hat world. You'll see there's a Docker socket activated, right? But there's no daemon connected to this socket. What's happening here is this thing is fired up and it's listening, but systemd is actually listening to it. So, and I'll show you how. So let's go to systemd, systemctl status, podman.socket, and then you'll be able to see what's going on here. So you'll see what's happening is systemd is basically saying, hey, I'm listening on this socket. Whenever I go to like fire this thing up, like go basically run podman. Then we'll go look at this. This is here it is. Let's just grab this guy. We'll go show you what this looks like. Not hard. it's actually quite simple. It just basically says, oh, listen on this stream. I even set the mode so only root can talk to it. And then you'll see if I like log in as a regular user, try to connect to this, it'll fail because I set the, set it unless you're in the Docker group or the group of whatever this socket is, you won't be able to connect to it. But let's actually show you the service too. So what happens is it'll actually every time it sees that, kind of like XINetD did back in the day. It will go
yeah.
It'll basically go fire off this command every time you talk to that socket.
Nice.
So you'll see, and then this command, you'll see actually what by default this runs for like 5 seconds or something. I think is how long it fires up for. It fires up for just long enough for you to basically go talk to the API, fire off your command, and then it shuts itself back down. So you'll see it's a one shot. What's called a one shot. I think it's wired into Podman the default time, which if I remember right, it's 5 seconds. So it's pretty interesting, right? Like you're like, okay, I don't need, but if you, and this is what I was getting at, like people go, well, how does this work, right? Like what does Podman talk to that knows how to do this? Like nothing. That's the funny part. There's nothing. It just goes into varlog or varlib containers. And then there's a bunch of data in here. Like if you, oops, let me not do that. Let me do it only. Yeah. There's a whole bunch of junk in here. And some of this is like storage. Some of it is like overlay layers, but some of it is metadata. Like it knows like config.json, for example, you'll notice that there's a certain number of config.jsons in here. And I use these as the example here. Let's grep for it actually. Grep config.json. Should be like 5 of them or 6.
6.
All right. So now coincidentally, let's do this. Podman ps-a. You'll just happen to notice that there happen to be 6. There happens to be 6 containers that have been run, right? And if I do a podman killed or rm-a, let's remove all the metadata for all containers that exist and completely remove them, right? So let's see what happens now. There's no config.jsons. So the container engine is smart enough, Podman in this case is smart enough to go delete all that metadata, right? And so you can start to think about containers are really nothing more than a bunch of user space metadata. Docker does this, Podman does this, Cryo does this, Containerd does this. Like every container engine does
this a different way. Yeah.
Yeah. Internally, how they represent it's irrelevant, but they all do have config.jsons. That's important to know.
Right.
But yeah, they store it in wherever they want, whatever directory and however they want, and then whatever other metadata they want. But the funny part about this is you'll see like Docker, right? So let's do a Docker run. Let's run this. This is pretty funny. This actually made me chuckle when I did this. So like let's run like. Actually, no. Before we do that, let's do a Docker info because this is actually pretty funny. So you'll see, like, you've probably never seen this output in a Docker info. But it is pretty funny when you get in here and you go, what server version says 2.0.0-dev. And then it shows it's overlay with XFS. You're like, okay, I recognize some of these things.
Okay.
You can run. It has different runtimes configured, Kata, runc, default is crun. And again, that's kind of why I showed you the drawing. Like there's these, the 99% of the world uses runc, but I got the system configured to basically fire up with runc. Actually, I should say default. I think it's 31, 32, and 33 is crun. And then yeah, Kata and runc I have configured as well.
Nice.
And then you'll see it's Fedora, blah, blah, blah. Here's the name of this host. Here's how much RAM, blah, blah, blah. But the hilarious part about this is that it even shows the license, but this is Podman responding, right?
Right.
Like that's what's funnier than this. It doesn't say it. You can kind of tell from that 2.
Yeah. The version number is kind of a giveaway.
Yeah, kind of a giveaway. And then you'll also notice all of it's showing where's the Docker root directory. Oh, it's in varlib container storage. And so if you do a Podman info, you'll obviously see a little bit better output because it knows exactly what it wants, right?
Yep.
And it shows the path for conmon. These are things that you would never see in Docker because Docker has no notion of conmon.
Right. Cool.
But yeah, so this is kind of funny, right? So here's what I do. So let's fire up a container. Let's fire up one with Docker. The Docker client. Now, mind you, this is the Docker client. Actually, let me make sure. I want to show you this. So systemd or systemctl status dockerd or Docker. There is a socket, but but there's no.
It's not running.
You see, it's disabled. Yeah, preset disabled. So like, there's nothing running, and you can obviously do a ps-ef grep docker. There's nothing running, but yet I'm still getting. That's the funny part. But yet it's getting Podman's getting activated off that
nice.
socket activation. So let's do this one's my favorite one. So do an IT UBI8 bash. So let's like go fire up a container.
All right. For those who aren't familiar, UBI is the universal base image.
Yeah.
Super, super awesome ways to just, if I need to test something Red Hat related, but don't necessarily want to have the entire system spun up, because grab me a UBI and off I go.
This is interesting.
You having connectivity issues across the board, or?
I'm wondering what's going on. Let's do this. Every now and then we get a little. Let's do this. Well, I have noticed I got my socket seems to have hung. That's not fun.
That's because you poked it too many times.
Oh no, something went wrong. Let's do this. PS-EF.
Well, it's not a live demo unless something breaks.
That's right. Let's kill this guy.
Okay. Whatever it's doing, go away.
Let's just go away, die.
Okay.
I think that thing hung is what I suspect. And then let's do a status on that socket again. Okay, you see the last message says listening on Podman API socket. That should be good. I think that's good. Docker PS. There we go.
All right.
There we go. Now, I will warn you, this is obviously alpha. Like, we are definitely experimenting here, but no, there's this error came out, blah, blah, blah. Actually, this has something to do with the timeouts and the way Docker expects something to come back. I just talked to Matt Heon, who works on the Podman project, and he said they're still working on it. But in the end, it doesn't really matter, because to me as a hacker, I'm just laughing my butt off, because if you look here, I'm in a container. Like, I'm in a terminal that is connected through a socket that got activated by systemd to Conmon, because actually you talked to Conmon. Podman's long gone, right? Like, it fired up and it's gone now.
It's ancient history at this point.
Yeah, Podman and runc are long gone, because they just do like one-time job to fire up the container, and then they're gone. And now Docker is connected through this socket to Conmon. Actually, I may lie. When you do it this way, it may actually still be talking to Podman. I'm not sure. Let's see. So there is still a Podman running,
but that's just the socket last time. I see Conmon. I see Podman like last time.
Yeah, this is for sure how you're getting the terminal input output out of the container.
Yep.
It's basically taking it out of that namespace and piping it back through to, like, the root area, or whatever you want to call it, to the main user space. And then I think what's happening is Podman is talking to Conmon, and then Docker's talking to the socket. And then the socket is talking to Podman, which is talking to Conmon, which is talking to Bash.
Mm-hmm.
So basically, in this scenario, while you have this terminal fired up, there should be a process running that's piping that data back and forth.
Wow.
Yeah, so it's fired up like a Docker daemon right now, basically, until I get out of here. But if I get rid of, here's a way that I can show you how to do it without that. Let's do it like this. So let's fire up in the background as a daemon.
Yeah.
You'll see now it's gone. It should be gone. So there would be nothing now. You basically just did it daemonless, even with Docker, which is even funnier, because Docker talked to the socket. Systemd noticed somebody's talking to the socket, said, "Oh, hey, Podman, go fill this request." Then Podman did it, fired up runc, which then kicked off the container, and now, it's in the background.
Mm-hmm.
Although I don't see a Conmon in there. It's almost like that container died.
Did it spin up and then die because you didn't give it anything after bash?
Yeah, there's still some glitches when you do runs with Docker. So let's try this with Podman. This is even funnier. Let's do an ID UBI8 bash. So now we'll fire up a container in the background with Podman.
Run. Yeah.
Forget the run.
Yeah.
So let's do this. Okay. Now let's look. And there it is. We see one run in there. Huh. Now watch this. We can do a Docker PS. We can do a Docker exec, which is really funny. -IT, and then we'll get into this guy, and then let's run bash. Now we're in a container that was fired up by Podman. I
How
find
many
that
ways are we going to skin this cat?
I find this ridiculously funny.
Yeah, like it's so interesting how all of this just rides on top of System D.
Yeah.
That's what it feels like, at least.
Yeah. It's again, that's the socket that does, or that's the daemon that does all the work.
Yeah.
Now let's do even more fun though. Let's get into, because that's kind of fun. All right. So now you're back to like where you were with Docker, basically, right? Like where you have something running as root, it can fire up containers. Let's get out of here. Let's get in here as Father Linux. So this gets even more fun. So let's get in there. So now we're logged in both, into this system, this Fedora system that's a VM on my system, that I showed you.
Right.
Now let's do this. Let's do now this time if we try to use Docker PS, it'll fail because I'm not allowed to talk to that thing. Now I'm permission denied, right? Because that's a root socket.
Yeah.
So if I were allowed to do that, that would be a security problem because I'd be basically root on the system. So what I do here is let's do this. Let's export. So I'm going to tell it to talk to a socket in my home directory.
Okay.
And then I'm going to run that same Docker command again. And then we're going to see if it works. And it's going to hang again. But it's trying. Systemd is trying to fire Docker.
That is funny.
Podman. Come on, Systemd. What are you doing to me?
Just sitting there hanging.
Let's see what that's going on.
Like, yeah.
Defunct. That's not good.
No.
That's
bad.
Issue. Yeah, let's do this. All right, let's get out. Let's try this. Restart. Actually, let's do.
Dang.
You're gonna have some.
Yeah.
It's still a little.
Quite the history. Yeah.
So you'll notice this command here. Let's do this. -- now. Oh, it won't shut down. Let's do this -- enable now. So this -- user basically says, "Hey, I've got."
Me. Yeah.
Yeah. Maybe it's just enable. Sorry. So it's saying, "Hey, copy this bad boy right here." To point, or I'm sorry, create this guy that goes and points to this. So I went and created this.
Mm-hmm.
Although it's not liking firing that socket up. There's something going on here.
Okay.
Let's view this real quick so you can see what's going on. So again, in my home directory, let's actually go do it this way. .config. You go into systemd. A lot of people don't know about this feature. If you create a directory in your home directory, like .config/systemd, you can create a user directory. You go into this guy, you can actually create service and socket files if you want. And then actually you can even, this gets created by systemd itself. But basically what this is saying is, hey, when you log in, fire up the service or make sure the socket is listening so that basically when I go talk to that socket, it'll go fire up Podman.
That's amazing.
And so look, this looks just like that.
Any other unit file. Yeah.
Yeah, it looks. In fact, I just copied it from the root one, and then I just modified this. That's all I did. I just added this string because what happens is Podman has a system command. You can service, and then you can basically point it to. You could tell it where you want to listen. And I was like, well, let's make it the docker.sock in my home directory. I just arbitrarily picked it, and then as long as you export that, I could add to my bash file to export that variable I showed you, so it always listens.
Wow.
But let's try and kill all. Let's try to get this thing running.
Yeah.
Again, because I think it's even more funny. Let's do it as root. We need the powers of root sometimes.
Is there a Podman exec?
Yes.
That's a question from chat. Yes, there is. Okay.
Oh yeah. So like if you run Podman run -it, actually it's run in the back UBI 8.
Yeah, you just did that. Yeah.
Yeah, and then we do a Podman exec -it. Yeah, sorry, I skipped over the basics. I just went right.
No, you're
for the
fine.
gold.
Yeah.
And then you look at this bash. So yeah, boom, you're in there. And if you look, you're in an Etsy Red Hat release. You're in a rel. You're in a UBI, rel 8.1 container basically.
Mm-hmm.
Now when we get out of here, let's do a Podman kill. I still think my laptop is not happy in a certain way.
Really?
Look, what's it doing to me today? I've never had this happen ever.
Of course.
I may have to
It's
reboot
probably,
reboot
it's
this
either,
Fedora
it's
box.
one of two things. It's Fedora not liking the screen share, right? Like,
Yeah.
or it's just
Watch how ruthless I am. I am ruthless to my virtual
force
machine.
off. You just immediately just kill that.
I don't even reboot them. I just do this to them.
Wow.
I'm like ruthless. I do it to relate all the time. I abuse
Well, I
it.
guess you
I
could
don't do it to
relate.
CRC because it's a little more sensitive. It's a
Yeah.
sensitive flower.
Yeah. No, it has a certain order of operations.
Yeah. But I will abuse Fedora and Rel. All right. Yeah, I think it was something wacky. So let's give it a second to reboot. VM in a little while, but because you saw it disconnected from the network, which was interesting. But
yeah.
Let's see.
The
There we go. All right. Now we have a fresh box. PS-EF. We probably shouldn't have any. Let's do this. We probably shouldn't have any Podmans running. Nope, no Podmans running.
No Podmans.
All right, now let's try this. So let's do let's do that. But also let's do this. So let's do Podman PS. You'll see.
Okay.
There is something there. Interesting.
Oh. Was that the container that you just had when you killed the box? Yes.
I think it did. I think it got
so you've got
funky.
the metadata left over. Yeah.
Yeah. So all right. So now we have a clear as a rootless Podman. So here's the thing for people to understand about rootless. So I was showing everything as root before, and everything's in varlib containers. But if I'm logged in as a user, everything is in .config, and then it's in containers. So this is like my own.
Nice.
Oh, and actually, I think I lied. Where is? Let's do this. Podman info. Yeah. Sorry, it's in .local. Yeah.
Yeah.
See, here's where everything is. Yeah. Sorry. The .config is for you saw my containers. I do have a config file for like containers.conf and for storage.conf. So this is like what tells it to use like this is what tells it to use like fuse overlay and stuff like that. So we can't use root overlay because we're not root. We couldn't mount and unmount file systems, but we can use fuse overlay. So we basically use a
fuse
user space file system. And then everything's in .local. So if you see the
local, totally could run containers locally in your own environment, non-root user, just fine.
Yep. If you look Podman images, I've got my own images, which are separate. So look, I'm logged in as root here, and here's all the images I have locally. If I log in as root Podman images, you'll see it's different. So like,
it's a different list.
Set of storage.
Yeah. Wow.
Yep, because this is what's in varlib storage or varlib container storage, and then this is what's in my local .local.
Your .local storage, whatever directory. Yeah, cool.
Yeah. So now, all right, now let's see how brave I am to try.
And handy.
All right, now let's see how brave I am.
Oh boy!
Come on, really? You're gonna do this to me? It worked so well before.
Of course.
Oh, there we go. Oh,
there we go. Just needed to warm up. Okay.
It just needed a little love. And so you'll see now when I run Docker command, I'm again connecting to that socket I mentioned. I'm running a container. This is even funnier. I'm running a container with runc, and I'm, it shows the kernel, blah, blah, blah. Shows that all of my container storage is here in .local. Now let's run a container because this is actually the magic. Run -it ubi8 bash. And look at that. I am root in the container, but I am a regular user.
But what are the security concerns with this?
Well, the beauty here is you're a regular user.
You're just a regular user. So whatever you're doing in the container, be whatever you want.
Yep. But here, let's run a different
So the power of this, I feel like, is almost too much. So how do you limit such power, right? Like, how do you, if I'm a sysadmin and I have large boxes across my infrastructure, then all of a sudden all these pods start spinning up in everybody's user environments, and all of a sudden no one's asking me for root access anymore.
Well, that's good, right?
I guess. Yeah. I mean, you're you know.
Well,
Wow.
we've at least got what this does is it takes you back like when 1999, I was a
When you had your own box, yeah.
Well,
Like,
I was just admin at university, and like we would give people shell access to a shared box, right?
yeah.
And you could do whatever you wanted in your home directory, and you could fire up whatever processes you wanted, and then you're relying on the security of Podman and then the Linux system itself, like in our case, Red Hat, which then has SE Linux and all kinds of other things that are stopping it. So like this is still limited by SE Linux. It can't do anything that I don't let, that the sysadmin or the policy doesn't allow. And so we've got it
absolutely right. But yes, I can run all these processes now in an environment where I don't have to grant people root access, which is so very, 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 very handy for everybody that needs their app that has to run as root. But that's not necessarily like a good paradigm to even program as anymore, right? Like your app should not run as root. So
yeah, so here's the funnier part. Okay, so yeah, let's see if this works. So yeah, in a perfect world, what we would do is this. I always use a sync user.
Oh, okay.
So now if you do who am I, I think it failed. It didn't like that.
No, it didn't.
Let me do it as Podman. Podman run.
You have localhost stuff.
User sync, and then let's do UBI8 bash.
Mm-hmm.
So now let's do a who am I. You'll see I'm the sync user inside the container. But if you get out of the container, who am I? I'm Father Linux. That's the most secure. That's what you would prefer, that the whole world does that. Not gonna lie. But if you don't do that, if you just run it normally, let's do this apparently doesn't like sync. Permission denied. Oh, because I'm not allowed to run that as sync. That's funny because I didn't. It's probably an SE Linux thing blocking.
It is an SE Linux thing, I bet.
Yeah. So here, I can't do that because my system is smarter than me and it stops me from doing dumb things.
But you can do
but
that.
If you do who am I now, I'm root, right? Like, so it looks like I'm root in the container. But what's really happening outside the container, we can go look at. We can do a PS, PS tree dash, I think it's -A.
Okay, here we go.
That's
right there. API conmon. Yeah, that's your bash.
There's the command that got fired up. Right, it's talking to that socket.
Yep.
You'll notice it's talking to that socket. Then if you go over to,
I think it's lower.
Is it lower? It might be lower.
Conmon.
There it is.
There it is.
You see that? Actually, no. The funnier part is it is not still. You have these sockets, but they're not connected to anything. So then I think it's right here.
That's it right there then. Okay. Huh.
That's it. There it is, the bash 2. So it's, you notice it is under, you're right. So like when Podman fires it off, it's still a peer. Notice it's a peer of it. Systemd is still the user version of Systemd. This is the system running at me. Has its own, like, all of its shizzle going on.
Yeah. That's awesome.
Yeah. So basically I have true rootless now. Now I'm using the Docker command, which can be in the system. It's in user bin or wherever it is, but it's talking to this local Podman, to basically this local Podman socket and firing up things.
That's amazing. Okay, cool.
So yeah, I was pretty excited by this. And then here, if you want to see that, you can also do this. Like, let's do a curl. People can start.
Okay, yeah, go ahead.
So look, what I'm doing is I'm telling it, talk to this thing like a Unix socket.
Yep.
Here's the socket, but here's the actual REST
file path.
endpoint.
Yeah.
Here's the endpoint, and then I'll pipe it to JQ so it's pretty.
It's empty.
It must be. Did I kill that thing?
Oh, did you?
Oh no, it's because I'm talking to the root socket. Let's go to.
That'll do.
What is it? Father Linux. Let's do.
Yeah, it'll be your
home.
3 slashes with home, Father Linux, Docker socket, whatever. Yeah.
There we go.
Yeah.
There's your container that's running.
Holy smokes.
And obviously, as root, I can go and talk to the socket that is fired up by Father Linux because I'm root. But another user couldn't go talk to my socket because it's in my home directory.
So, question coming in from YouTube. two questions. One from Waleed, our good friend. So Docker client is talking to Podman. I missed that.
Yeah.
Yes.
Yeah. It's talking to Podman through a socket.
Yeah. Second question is, does this make it, and you might not know the answer to this, I assume I know the answer to this, does this make possible to have GitLab Docker runners with Podman underneath? In theory, yes, but I don't know how well that actually works in GitLab land. I mean, I don't know.
Yeah.
To be honest with you, I don't know enough about GitLab and GitLab runners to say that, yeah, you could have Podman in there, but you could totally build a pipeline with GitLab as part of their like GitLab CI that uses Podman.
Yeah,
So
you can. My understanding is like you can probably create like custom runners that have like a VM that goes off and fires up Podman, and yeah, you could have it go talk to this API probably to go fire up, because I think GitLab only speaks the Docker protocol. I think. And
well,
so
yeah,
theoretically, one of the reasons why we enabled this or why we worked so hard on it is because we know there's a lot of existing software like GitLab, like GitHub, GitHub runners, like all kinds of things. I talk to customers all the time that have like weird pieces of homegrown, whatever, like just like this curl command. Like if I had this thing embedded in a piece of code somewhere, like, and I'm like, I don't want to unwind this because it already works, so it works, right? Like,
yeah,
theoretically, in a perfect world, as long as you're not doing anything too crazy, you should just be able to go talk to this socket that Podman, that systemd has fired up, and it should be able to communicate with it. Now, that said, there are some edge cases. Like we already know there's definitely some certain things. Like if you're doing weird stuff with like Docker network or Docker, especially those Docker commands that aren't ephemeral, they're things that go and configure the daemon and do weird stuff like that. Like mileage may vary there, right? Like there's no way Podman will ever be able to do that kind of stuff. But if you're just firing up containers and killing them and running them, it should be able to do that pretty easily.
That's amazing stuff, man. That's so cool. Just sitting right there in my home directory, I can run containers without a daemon or anything. I can run them as root, no problem. Very, very nifty.
Non-root, no problem.
Yeah, right. Like that's what I meant. Yeah, run them as non-root, but be root in the container. Yes.
Yeah.
The app can act like it has root.
I like doing this. You can see the info like I showed you.
Wow.
You can see it through the API. And this is something that we showed the Docker command knows how to parse this, right? Like that's the funny part. Like it's good enough at this point, the API, that we're feeling pretty good about it. So probably RHEL 8.3 will have the like 99% chance we'll have it in RHEL 8.3, and we'll probably make a tech preview. I mean, I'm like, again, I'm as a product manager, I'm not supposed to make these commitments, but my plan is to have it tech preview. My roadmap is to have it tech preview. We will not. I can promise you, we're not going to make it GA in RHEL 8.3.
No,
but it is good enough that I think it's time for people to start using it, playing with it, finding bugs, helping us get it, even further.
Absolutely.
See if it meets the use cases.
Yeah, like there's, I mean, I want to run a WordPress blog, but I don't want to have to deal with all this extra, permissions and all this other nonsense, right? Like any app at this point, I just put it in a pod, put it in my home directory, export the socket, done. Like it doesn't matter.
Yeah, and for rootless Podman, if you're okay just using the CLI, rootless Podman has been supported since RHEL 8.2 basically.
Right.
And so you go, okay, we were the first to GA like a rootless solution that's like truly rootless. And that today out of the box works. Like if you have a RHEL 8.2 system and you just like literally you kickstart a box or install it, click next, and then you do user add father Linux, and then you log in as that father Linux user. You can type Podman, and then before that you need to do a yum install Podman or yum module install container -tools : RHEL 8 or something like that. Right. But either way, once you get Podman installed, you literally add the user. You just log in as a user and you can type Podman and it'll fire up containers. There's like no extra configuration.
No work whatsoever. No, like that's...
If you have API requirements where like you have a piece of code that is doing like the equivalent of that curl, like say you have Python code that is hard coded to go talk to the API, then you need Podman 2.0 with the socket.
Nice. Okay. That's dope. That's amazing. Like that's a really cool feature. Like I'm very excited
excited by it.
Yeah, like I'm very excited to tinker with this now, right? Because like I can think of all kinds of fun like little things that I can do now, right? Like I don't necessarily need much of anything anymore from my root OS, right? Like I just need you to provide me a stable container platform, which is Podman. Done.
Yeah, you just need an API.
Does
And a
this
couple
mean that
places.
Podman will finally work with Kind? Oh, with
So
the
this is
API
funny. I
conversion.
don't know what kind. I mean, I vaguely know what kind is, but I don't even know what it does. I can't. I looked at it like years ago or whatever, but I don't remember what it does.
Yeah,
Let's
so
for
Kubernetes
all the
and
users.
Docker. I mean, it's
Bring
like
it up.
Minikube, but it uses Docker, containers as hosts, essentially as host nodes. So yeah, Kubernetes and Docker. Ben Elder is, I think, the lead developer, and I put in a quote live patch as I yelled it across the room in San Diego at the new contributor workshop. So yeah,
Okay.
that's my familiarity with Kind is getting it patched for the new contributor workshop in San Diego last year at KubeCon. So yeah,
What
but
does
it
it do though?
is
Does it install a Kubernetes cluster? Is that what it does?
yeah, it puts a Kubernetes cluster, but like, and you know how like on uh, Docker for Mac, it's just running, it's constantly running. There's a VM sitting there. So instead of
Yeah.
having this other Minikube VM and this other Docker VM, I can now just have this one Docker for Mac thing, brew install Kind, and off I go. Right? Like I'm
Okay.
using the Docker VM now as opposed to the Minikube VM, and each node is actually a container. So
Okay.
yeah.
I don't know if this will work
So
with our.
Christian and I went down this rabbit hole with Podman, 1.x or whatever, and Ben pretty much said not yet. It's not quite. They do make some API calls and so forth, so on. So I'm curious now if we could maybe. Oh, and yeah, well, he just dropped the link in chat.
Yeah, it sounds like we might be able to do it with code-ready containers. So a lot of people don't know
Well,
that the
definitely with
code-ready
that.
containers.
Yeah.
Well, the code-ready. So there's sort of two things in code-ready containers. There's they haven't released it yet, but they're working on having essentially two versions. Like it'll be the same version, but you would be able to run it with OpenShift fired up, which does use a lot of resources, or you'll be able to
Mhm.
use it without OpenShift fired up and just connect to it with a remote Podman API. So like it'll be like Docker for Mac, but we're going to call it basically Podman for Mac, Podman for Windows.
Nice.
And in that scenario, maybe Kind would be able to talk to that VM through Podman or something like that. But I'll have to admit mileage may vary. Obviously, our goal is to get CRC as kind of our one all-in-one thingy.
Yeah.
You know?
Yeah. No, that makes total sense. Given everything that's gone on in the industry around containers. So, any other questions from chat before we move on to the next thing? I DM'd you the GitHub issue for Podman Kind thing. Christian and I also asked about that. I think this is the same issue a while back. So you wanted to do something CRC requirement is heavy compared to Kind. Well, that's putting it mildly, but yeah. I mean, and Kind's requirement is I think 9 megs of storage space, to be honest with you, because it uses Docker on your local machine. So that's like a major dependency that is you just kind of omit with Kind. When can I DNF update Podman in a Fedora 32 box to get Podman 2.0? I don't think we're anywhere near that yet. Or how? I mean, how close are we to Podman 2.0?
This is in Fedora Rawhide right now.
Right now,
You'll
it's in
probably see
Rawhide.
it drop in Fedora. I would guess 33. I don't know. We'll have to see, but I think it will be. And then we're targeting Rel 8.3, which will be the fall.
Yeah,
So we're going to spend the next
fallish.
few months stabilizing,
Yeah.
stabilizing this like crazy, and then by fall we should release it in Rel 8.3.
Sweet. So, did you want to shift gears here? You want to take a quick breather and then shift gears? What's up?
Yeah, let's shift gears.
All right, jump right into this thing. So, now we are joined again by the illustrious Scott McCarty here. We're going to look under the hood at Kata Containers, runc, and crun. And Scott, you can explain the differences, maybe like give everybody a lay of the land of those three container engines, maybe.
Yeah, that's cool. And then let me set this hierarchy. I gotta do this.
this all
Let's do this and then
live.
reboot my bad boy. Reboot this. It seems my computer has decided to start running better.
Oh, good.
Watch, I'm still gonna be ruthless to this thing. Boom.
Maybe if you
It hurts
treated
me.
your VMs nicer, they'd be nicer to
I
you.
don't care about them. They're just like lab mice to me. It's like beyond cattle. People make that cattle comparison. That thing doesn't make any sense. But lab mice, all the time, they're just burned up. All kinds of experiments.
Wow.
I know it's horrible. I treat my VMs really poorly. I won't deny. I have very little ethics with my VMs.
I don't blame you. I mean, if you know that you're going to just toss them when you're done or whatever, yeah, why not?
Oh no, I keep these things running. Like,
oh, you do?
I'll keep this thing installed for like 6 months, and I've never had it break. Like, which is pretty amazing because I am ruthless. But all right, let's see if as I say that it decides to implode.
Watch it, not even gonna come back. Yeah,
I know it did. No, it did. Look at that.
There it is. All right, here we go.
I do to it. Yep.
All right. Cool.
So let's do this though. I will say, I think. Let's see if let's put this thing in desktop mode. Make sure it's in. Make sure it's in that. All right.
Okay.
Yeah. So. Oh. Yeah. So I think this thing should be. Let's cat / Where is that thing?
Yeah,
I can't remember. Yeah. I want to show people where this is at.
You catted a bunch of crap.
I know. I cat a lot of stuff.
You cat tons of stuff. It's almost like
I do. I'm like a 1990s sysadmin. I just cat everything.
Cat. Now everybody uses less.
Cat / I think that's it. There we go. Boom. All right. So notice this bad boy. I basically am saying go to cgroups v1 here is what I'm doing. I'm forcing Linux, like, so Fedora 31, I think it was, and above.
Yeah, they changed
to cgroups
v2. Yeah.
Which caused quite a hoopla.
Such pain. I mean, I understand why. I get it. But exactly. Like for anything that I'm doing today,
progress. Progress. We must make progress.
I know it has to happen at some time. Band-Aid has to get pulled off.
You're like, my daughter, she's 2. She does not like the Band-Aid.
No, Max just had his first like serious bad fall, and his whole Band-Aid experience was like, yeah, I've tortured or seen torture videos that were less like dramatic than this.
I know.
Yeah, it's not fun for my anxiety and everything else. But yeah, I get it. Yeah, you've got to rip off the Band-Aid at some point.
You got to do it. The whole point of Fedora is to basically experiment and do this. And I'll be honest with you, we've made really good progress. We're even making progress with runc now, which is awesome, right? And we've had really good collaboration with some of the Docker folks and with like Michael Crosby and stuff, and a bunch of runc contributors that like are interested in doing it. And we all knew it was chickens and eggs everywhere, right? We were like, where do we make the chickens and where do we make the eggs? It's just one of those things where like at some point one of the distros has to do it, and
someone's got.
This happens to be the distro where Dan Walsh has the most influence.
Shout out to Dan.
Shout out to Dan. Yeah, we're like, let's just forget about Fedora 31 and 32. Like Fedora 33, we're good again. I think it's to be honest with you, I was blown away. Even me, I will not deny I am a curmudgeon. Like, right? Like I run a RHEL 8 system. Like you run my dude, I run RHEL 8 all day, every day. Like this bad boy has been running for, I don't know, since I got this laptop. It's been RHEL 8, RHEL 8.0, all the way to RHEL 8.2. And it's been pretty like ridiculously stable. Yeah. So like, I don't like experimenting with my underlying system. I will experiment with my Fedora system in a VM. I would argue I am doing it the proper way. And if you were running Fedora on your laptop and then experimenting with RHEL, what are you doing? Like, I mean, like, do you need some latest, greatest GNOME feature that you're like dying to not have? I mean, I'm not
actually, yes.
Really?
Actually, yes.
Really? I knew it.
So,
I'm a curmudgeon.
Yeah, no, like there's a bunch of stuff on my Fedora rig. For example, I'm on a Mac right now for lots of reasons, but mainly hardware compatibility. But the whole stream gets broadcast on a Fedora box. But there's all these little caveats with OBS and Zoom and all these plugins and everything else. You got to run in Xorg mode. and then you have to, there's some patch that I need that is coming down the pipeline, I'm told, to allow, because I do, anytime I have to, like, anytime there's a stream, I do this number. And now we're live because the remote desktop is not enabled in Xorg. Like, there's no package for it. It's completely like not a feature in Xorg anymore. So it's like, wait, if you have the option in the toggle, shouldn't it like be available? Otherwise, just get rid of the toggle. Like, I had a bug report put in for Fedora 32 because it's like, I need this in Xorgs, but
did this exist in older versions? See, you're proving my point.
I don't
just
know.
stick on the older version.
I don't know.
Whatever.
I don't know, man. I don't
Tearing
know.
stuff out seems to be a feature a lot nowadays. Like,
yeah,
that seems to be like the 2010s to 2020 is like tearing stuff out as a feature.
Yeah.
I'm like, no, that's not a feature. That hurts my feelings.
I want to be able to remotely control the box. Anyways, all right.
So all right, so this gets fun. We
All
should
right.
be able to do some really funny stuff here. So let's do Podman info. So by default, Podman runs. I'll bring back up my drawing since, like you said, some people may have joined late. So I showed here, I show here 3 different container engines. I show Podman, CRU, and Docker. But really what I should do is also then show, like, let's do this for, I can't do it, darn it. What I'm showing is that the container runtime, runc is what everybody uses by default. But I'm going to show you that you can swap this guy out. You could swap this thing out and it won't hurt anything. You can run, here, let me see. I have slides on this because I'm that guy. All right, so this is an old drawing, so I'm gonna probably some of this is wrong now.
Well, of course, any drawing that's more than 5 minutes old, it's probably wrong.
No longer is this 9p. Let's see if we can fix this live. Nope, we can't because I think that's a drawing. Yep, I'll have to do it later. We used to show that the main takeaway here. This is OpenShift. This is like the OpenShift master. This is the node, and then this is the kubelet proxy. Kubelet. And then the proxy. And so basically you could think of this as just the kubelet. Just think of this as a kubelet. Kubelet talks to CRU talks to runc, which used to be called runc. Now it's called Kata runtime. And then Kata runtime goes and talks to, I can't remember exactly, one of these two. I think Kata proxy, Kata shim. I can't remember because it's been so long. Then it basically goes and talks to, KVM or whatever to go fire up a VM, fires up this virtual machine, which you can think of virtual machine as a process, because a virtual machine is just a process.
It's just a process, just like a container. Yeah.
Just like a container. Then we fire up another process inside of this virtual machine. And then we like, if you do a bind mount -v bind mount, it has to communicate the overlay files. It has to be able to communicate back to the kernel that, hey, we got to share this. Like if we share like /srv into the container, that normally would just literally be a bind mount. But when it's in a VM, we have to like have some virtual device that passes it in. And so actually we're using virtiofs now. And then, every time this thing happens, it has to make hyper calls into the kernel, right? Because it's now this isn't just making system calls anymore. Regular container just makes system calls and just, bind mounts the data. Whereas this, you got to go through to get storage. You got to go through this. The network's actually almost the same, which is why I don't show it. It's really the storage and then the hyper calls that are different with Kata.
Okay.
So here, let's show what that looks like in real life. So the beauty of Podman is you can do really funny stuff like run dash.
You can do really funny stuff. Make clowns with it.
You can do. Oh yeah, you can have. It'll actually fire up a bounce castle if you want. It'll bring it over on your kid's birthday. Like it does all kinds of crazy stuff. Jesus. I mean, it does.
I can't wait till a future stream when someone's like, "Hey Scott, I turned on Podman. That bouncy castle never showed up."
Never showed up. I know. Well, not yet. It's on the roadmap, but I mean, it's
typical.
Yeah. Okay, hold on. So check this out. And this is one of those ones where I'm like, please work. But no, I actually haven't had this fail, but it does take a little time because I'm running it.
Because you're spinning up a VM and then you're spinning up a container in the VM. Yeah. Like, so what is the use case for Kata? I mean, answer that one for me. Well, there it is.
Okay. Wow. So this is actually a really good question. No, it's a perfect question. So there's the most popular reason to run Kata, I would say, is the cloud providers, where they have all of them. name one. I won't name their names. I don't know, but like you know, all the big ones.
Yeah.
All the big ones.
Yeah, I know where Kata came from.
This, yeah, and they all find it interesting. And whether it's Cat or not is kind of relevant. Really, the point is that it's a VM. The reason why they do it is there are ways to pull down container images that will have an exploit in them, and it could, like, for example, we have a guy, Andre Angele. He showed me, literally, like, here's the commands to, like, he created a container image that will hack your box.
Nice.
You literally download it and he has root on your box.
Yeah,
like, if you type podman run or docker run, he has your box. And you're like, oh, that's terrifying.
No, there was some scan of there was some scan recently of like how many bit miners are in lingering, like images, container images around the internet.
That's only user space. Remember, we've always known about user space being terrifying. But like, if you don't have your box patched for Spectre, he modified Spectre so it will basically, I think it was Spectre Meltdown, that it will, like, he's got root on your box.
Whoa,
that's amazing. Also terrifying.
Also very.
I used to always joke. So here's a perfect use case. My buddy was a CTO at this company, startup out in Chicago. They were hiring developers. They sent the developer home with, like, homework project. Could you write this thing in Ruby with Postgres? Blah, blah, blah. They give them a little project, like a CRUD app, right? Like a create, update, read, update, delete app. Just a simple web app to kind of see how the person programs, see how they, how they respond to doing some team stuff, figuring out problems, blah, blah, blah.
Sure.
So this developer comes back and the developer says, here's all my code in GitHub. I created this repo. Oh, and by the way, here's this container image. I have it out on Docker Hub or whatever. You could just run it if you want. It already has Postgres in it. It has my app. It'll just run. The one hiring manager, she, like, downloaded the code, is like, I'm just going to, like, run this code. I'll figure it out. She ended up in the scenario where the schema file for his database was newer than the Postgres she had. So she ended up upgrading her Postgres system, breaking all this stuff. She literally spent 2 hours, because we all know how rat holes are.
Yep.
And she was like, son of a, like, I mean, you know that anger that you have in you when you're like, why didn't I just run that? So she farts around for 2 hours trying to figure this out, which I feel that pain. I know that pain.
I know that
pain.
And then
finally got it working and went, okay, now I can look at his code for half an hour or whatever, to review it. But you're already frustrated because you spent 2 hours farting around doing this stupid rat hole that you didn't want to do. My buddy, on the other hand, he just, like, downloads a container image, runs it. It's like, it works, like a redneck. And then he's like, and then he just spends a half an hour looking at the guy's code, or the programmer. I don't remember if it's a guy or girl, but code, the developer's code. And he spent a half an hour. The other hiring manager spent 2.5 hours. Wow. So that is a huge time savings. Now this is amazing. This tells you the value of containers. It also should be terrifying. Like, imagine if that developer's like, oh, I want to hack this company. I'm just going to get an interview here. I'll send him my container image. It has Spectre Meltdown in it. It installs something on the system. And now my buddy is running around with a root hacked laptop. And he's, like, connected to corporate. Yeah.
Woo.
That's one of the reasons why you would run Kata Containers, basically, in a nutshell.
Yeah. So that container can then isolate the process.
Well, yeah, now say they run Spectre Meltdown on this, they'll hack this VM, but they won't. Well, maybe they won't even be able to hack the VM. I don't know that much about Spectre Meltdown, but even if they could somehow say this processor, fake processor, had the things that got hacked, theoretically they'd have to then break through the hypervisor layer, through this hypercall layer, and then hack this kernel. So there's more layers to get through. It's just more defense in depth.
Right, and we can all hope that the VM is aware of Spectre and Meltdown. And would probably stop that. I think
most of the new ones are. I'm not a VM guy. I'm a container guy.
I hope that most of but like Langdon and I were on earlier this morning talking about, like, he was judging hackathons and how few hackathon, like, contests actually have, like, a Docker file associated with it, right? So we were building Docker files out of these hackathon projects that weren't really designed to be run more than, maybe for that one demo, which is cool. But now we can take that same project, have it safely running in a VM, not knowing anything about it, but it's also a container too. So we get 2 layers of management, essentially, right? Like, we get the flexibility of containers, but we get the protection of a VM. That's the idea.
Yeah, that's cool.
Yeah.
Yeah.
Okay. Cool.
I think another valid use case that I've seen for this is there's times I presented with Hitachi at Summit 2 years ago publicly about they have certain sysctl requirements. So like say your application requires you got to go tickle sysctl variables and tune some things to make it run right or make it run better. Containers, you can't do that. Like you cannot set sysctl variables in a container. Oh, are we not streaming?
No, we are.
Okay.
There's an echo apparently. I hear it in my
okay.
house, but I don't. I know I only hear it in my earphones. Weird.
Are people hearing it on the stream?
Yeah, but I just got to complain about it, and it's only my voice.
Oh, that's your problem then.
Yep. Yeah. No, I still hear it. Waleed, I'm looking for it. Keep talking, Scott.
Okay. So another, like I mentioned, a use case that I think is interesting for is actually sysctl variables, being able to have different kernels tuned the way you need them, still in a container. So like, and then another use case like that falls into a bigger set of use cases, which is basically anytime you're going to disable the technical controls that are in place for a container. So like if you run Podman or Docker or anything else with a -- privileged, that means you're basically disabling everything. You're disabling SE Linux, you're disabling seccomp, you're disabling C groups. The only thing that you're using is the container image format, basically. And so if you are using containers purely for a packaging mechanism and you're disabling all of the constraints, you pretty much need to run it in a VM or else it will basically be able to hack your system. And sometimes people do that for reasonable reasons. Like there's times where like they're using the container to modify the host. That's fine. That's a valid use case, but then that's a root. That's like giving somebody root, right? You better be able to trust them. But if you're doing it because your software won't run right, or you need to go set sysctl variables, or you got to do something like that, then and you're disabling all the controls, then you need a VM again to do it securely, or else you're basically saying, why aren't my containers secure when I disabled all the security? And you're like, well, that doesn't work.
Minor detail.
Yeah, minor details.
Yeah.
So, all right.
Okay, so someone says it's a left ear only stream. Is that correct? Let's see.
Uh-oh.
It's really weird. So I don't hear an echo. Now I do. It's delayed though. So wait a minute. Testing. Okay, that's weird. I have no idea where the echo is coming from, folks. I'm very sorry. I'll just stop talking. Actually, it might be my box right here. Let me reset this.
Uh-oh. What does uptime come in?
How about now? Weird. Okay. Right here for me. I don't. Well, I know there's audio, so let me just turn that off. There's no mic on the streaming box. I have it hardware disabled. So it's not coming from the streaming box. Is there still an echo out there, audience? Unless I lost the live chat too somehow. Oh no. All right, so what you got going on?
All right, so oh yeah, here we go. Exec. Oh, did I do that? So okay, so here's what I got going on. Podman PS. Let me see. I don't know what I got going on. I gotta figure it out. Let me kill everything. Podman RM-A.
Kill it all.
Yeah, it doesn't like that run thing. I've got this thing kind of hacked together with a bunch of different runtimes. So let's do the simplest one. So now that we've got this thing in, you'll see. Let's do podman-p podman run-id ubi8. Let's run I'll run these in the background. So run this thing in the background, and then do a podman ps. You'll see it's running. You do podman info or inspect. This is just running it the default way that we have podman configured. Let's see if it. I can't remember if it tells you what. Let's do this because I'll just grep. Nope. Podman info. Well, you can see it here. Podman info. You'll see that it shows like what the default is. Where's it at? Oh, it's running the default is runc now. I don't know why it put itself into that. That's interesting.
Didn't you have it set C run earlier?
Yeah, I did. That's why I don't understand what it did there. Huh. Yeah, it's interesting. All right, so
That's almost as weird as my mic problem.
Is it still going, yours?
Yeah, mine is, but if I talk quietly, I'm told no one hears it. But I can hear it in the background very faintly. It's weird.
I can't remember where this is at. RPM-Q L podman. Well, let's see where this thing's at. Nope.
Is that? No.
No, that's not going to happen. I meant locate. Let's see if locate works. Oh, there it is. All right, let's see. Pod. User share. Let's see if this thing, maybe this thing's set with runc or something. Huh. I think it's listening to this somehow. Because I thought I didn't put, I hacked around with this box a lot, so I don't know what all I've done.
Oh gosh.
And that's why I wasn't sure if I set up containers.conf, but I don't see it. Oops. Either way, well, here, it doesn't matter because we can just run them. We'll force it. So what we're going to do is run one container with runc, one with crun, and then we'll run one with Kata. We'll run 3 containers with 3 different runtimes, all using the same container engine using Podman. So
I'm here for this.
Yeah, let's do this. Let's do a runtime, runc. See if this works. I think you could just do it like that. Sometimes you can put in the whole full path, but I think it'll be smart enough to find it. Okay, so we ran it with runc, no problem. All right, now let's run another one with crun.
Okay.
Okay, we ran another one. So now let's see, Podman PS. We should have 2 running. Oh, we have 3 because we had that other one that we fired up a while ago. Yeah. Let's kill that one. Podman kill, so we don't have. All right, so now we have 2 running. And then let's do podman run -id. Let's do -- runtime equal, actually let's do this kata -runtime, and then ubi8 bash. Oh, that one I gotta do the whole thing. Oh, actually, if I'd have told it kata, it probably would have
just worked fine. Yeah.
Yeah. The thing is, Podman's a little looser than Docker. Docker has a little bit more strict the way you have to do it there. But the way Podman does it, it's just like it's actually awesome because it just figures it out most of the time. All right. So Podman is a tool for hackers like me. So you'll see I have 3 containers running, right? Like you can't really tell them apart.
Nope.
You can do inspect on these things. I don't know what happens. Let's do an inspect on that last one. See if it gives us any information. I don't think it will. Annotations, blah blah blah. I don't think it'll give it. You can't really tell what it got fired up by.
Keep going. Namespace overlay. Kata. There it is.
Oh wait, yeah. Well, boom, there it is.
Yeah.
So it's.
But that's only from the exit command that we found that.
Yeah, exactly. That's interesting. Yeah. So, all right. Let's actually go. Let's do. So, all right. So the cool part here is let's do a PS tree. What is happening?
You don't have your hands on the home row key.
I was gonna say I do not have my hands on the home run. All righty then. All right, so here's conmon. I don't know which one of these is which, but I could go look. But one of these two is with runc and the other one's with crun. And you really can't tell at this point because it doesn't matter because they're the same now. So these are processes in Linux, right? And you can see they're basically fired up the exact same way. This is where it gets interesting. So the job of a container engine, I always talk about this, is to go create this config. Here, let's do this guy. The job of the container engine is to take user input. You type commands, podman run. Then what happens is the container image builder creates image layers and image config. They can put things in this image config like IP address or host name or other wacky stuff, the command that should be run by default. And then what happens is the container engine has to be smart enough to parse what's in this config, what the user typed on the command line, defaults that the container engine itself wanted, like setcomp rules or SE Linux or whatever, C group stuff. Then config.json gets generated. This config.json, along with a directory, basically get passed off to the OCI runtime, which in normal case would be runc, but in our case, we did 3 different ones. And then runc talks to the kernel, fires up container. Once the container is running, the only thing that's left is runc, kernel, the container, and then, as I mentioned, conmon. So literally once, you can't tell these apart because we passed them basically the exact same config.json.
Right.
So it's hard to say which one got fired up with crun and which one got fired up with runc. But when you look at this one, that's different.
That's very different.
That's the one that's in a VM.
That is, yikes. Wow. Okay, so the
I
shim
had that Kata shim, virtualization.
Wow.
QEMU something other. But
yeah.
I don't even know exactly what that thing does. I know what that does. That's what handles the bind mounts. And then the Kata shim, I think, is what conmon talks to Kata shim to go talk to the
QEMU system looks like it's interfacing with KVM, so maybe it's actually the KVM VM.
Yeah, I think that's that's like the conmon for the VM, basically.
Yeah.
I think that's what that is. Yeah, it's actually like what keeps track of the VM.
So where's this image that hacks the box? You gonna run that on your fancy little VM
I
that you
do
don't
not
care
have
about?
that image. No, that image is not near my system.
Okay. No, I don't blame you.
So check this out. So let's get into this thing. Podman exec -I. Actually, let's do funnier than that. Docker PS. Let's do a Docker exec into because this is pretty funny. We can, in our last session, we showed that we have a socket fired up that Docker can talk to. So we can actually go look at, like, for example, this one we know is the KVM one, the one that's running with Kata containers. We can just exec into this thing, and then we can do like an uptime. And that thing has been up. Oh wait, why would it be up 27 minutes? That is not correct. I believe it failed. To put us in the container. Yeah, that failed.
Yeah.
Oh, maybe we have to do this. Check this out. Runtime.
Oh, do you have to specify the full?
Yeah, I think you might.
Oh, maybe.
Nope, didn't like it. Let's do
Is
this.
the Docker command not going to like it?
It might not. Yeah, it might not like it. But we can still get in there with Podman.
Yeah, exactly. Just get in.
Yeah. All right. So Podman exec -it. Let's get into this container. And it doesn't like that one either. Huh. Oh, it might be because it is not the default runtime. So when I set it to the default, it works. I know that because I've set it to default before.
Okay, so if you just do the runtime,
I think this might hack it. Let's see. Nope, still doesn't like it. Oh, you can't.
You said runtime bin bash. Did you mean to do that?
No, I did not.
I was about to say.
You are a better man.
Kata.
Runtime.
There we go.
There we go.
All right, there we go. So if you had set your config,
you gotta force it to know how to talk to it right, basically.
Right.
But yeah, it's interesting.
Wow. Okay.
Yes, it was trying to exec through runc to get into there apparently, which is going to fail.
That's going to fail miserably.
Yeah, and I'll actually bet the same thing will happen with the other two containers. We don't use crun or runc. I'll bet the same thing will happen.
What you'll know which one is not the default just because you try to exec into it. Huh. Okay.
I think so. We'll try it afterwards. So it's installed proc ps so we can see uptime on this thing because the kernels look the same, because the way Kata works is it fires up a copy of the kernel that's there. By default, it does that. So it fires up an extra copy of the kernel that is running on the underlying host. And actually, I don't know how this Kata is configured in Fedora, but I know Kata can be configured so it does like a copy on write kernel. So it doesn't even actually boot up an entirely another kernel. It actually does like copy on write memory. And so like whenever you like set sysctl variables in that other basically kernel, you're just like doing the diff between the two in memory. And so like, you can do some cool things. Yeah. Uptime. So you should see a fairly short uptime. Yes.
Yeah, there we go. All right.
There we go. And then, then the underlying host should be uptime 30 minutes. So there we go. So now we know we're in a VM, right?
Yeah.
Whereas if we get in, let's do podman ps on the other ones. Let's go into this one, which we fired up with crun, I think.
Yeah.
Podman exec -it. Let's see if we can get into this thing without telling it what. We didn't have to tell it what runtime.
I'll try the other one. Maybe we just forgot which one is what.
Yeah, podman or
yeah,
we know. Let's do let's do that. Let's do the third one. See if that's it.
Yeah.
There might be. It might actually not be. Yeah, it still works.
Are runc and crun like backwards compatible? I thought they were.
Well, the magic is I think you could use runc connect to one that was fired off by crun and vice versa.
Right.
Because they aren't VMs. So there's nothing magical. You don't have to go talk to that Kata shim.
It's just system calls still.
It's still system calls. It's
that
on
makes
the system.
Total sense.
You're just doing a clone syscall, adding another process to that.
Yeah.
So here I can show you.
Okay. What's
happening is you're doing a clone system call and you're adding. So when you fire up a normal process, you do an exec VE. Like if you're in Bash and you type PS, it dumps the contents of the PID, data structure, and then you're in the system C group, and that's set by by system D, and then you're in the whatever context your user's in. Whereas if you do it in a container, I do a Docker run here just to show you're doing a clone syscall, and then it adds basically all it does, it adds another process to this namespace. So crun or runc, either one can add another one. That's the funny part about it. Yeah, they don't really care. In fact, I'll bet I can do it with either one. Watch this. -- runtime crun. Yeah, you can do it either way. I'll bet it'll do it with runc too, because they don't care, because it's just going to do the same thing.
System calls. Yeah, that's cool.
Yep. And the funny part is crun is written in C, and this is programmed in Golang.
Go. Yeah. So.
Yeah, in Go.
Huh. I'm still trying to figure out where the echo's coming.
But they both provide an OCI compatible interface. So
right. So that's
when you tell Podman to give it the thing. Yep, it just works.
Yeah.
Yeah.
That's wild though. That's
it is wild, right?
That's so utilitarian and useful and just handy, right? Like if I don't trust this container, well, let's throw it in this runtime.
Yeah. And we're experimenting with crun. We'll probably also add it to RHEL 8.3. One of the main reasons we're doing it is because HPC. So crun, we can do some magical things with crun where we actually use it as a library and compile it into Podman. We're actually looking at doing that. Or into Conmon, I'm sorry. Conmon is written in C. A lot of people don't know that, but like the container manager is in C. And so we may compile it into Conmon. And so essentially you would just have Podman call conmon, and then conmon will have crun built in by default. So it wouldn't need to go through runc for example, for that exec command or other things. And it would also be super fast. So we're down to like finding the milliseconds kind of fast.
That's cool though. I mean,
most people could just use runc and never care. But if you're doing really heavy duty stuff.
Yeah.
If probably as an option.
If folks want to learn more about Podman, where should they go?
A good spot is podman.io. I will do a little bragging about our site.
As you should.
You can go to podman.io. It's awesome. You can go to documentation, which we actually just recently updated. We actually have we're like a real grown-up project now.
Wow, look at you.
And we even have commands. You can go look at that. But the more interesting thing is you can go to reference. And this is cool. This is that Podman API that I just showed you.
Yeah.
In the last one. We have the entire thing documented. So we have a Swagger site that basically shows you how to connect. So like if you want to delete blah 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 blah, and then also if you click here, you can go to the full page version.
Nice.
And so I actually did use this when I was constructing some of the things I did in the demo. I went and looked at our. One thing I should point out is there's a couple different. These are the okay. I'm going to try to talk about REST in the proper way because I am not a REST guy, but we have the root endpoint is basically compatible with Docker. And then we have so we label these as compat. These are the things that should work, right? Obviously, Docker doesn't have pods, so pods are never going to work. And then we have images right now is in libpod, although I think we'll probably eventually try to make this compat. We're trying to be honest with the documentation here. Like what's compat, what's not. We'll probably try to nail some of these things. Although it's funny, exec is working, although we don't have it listed as compat. But long story short is if you look at the API, let's go back to the curl real quick. Oops. I think we had a curl.
Yeah.
So you'll oh no, we don't have that thing fired up anymore, I think. Oh, there we go. Second time, it just hangs on the first one. I don't know why. You could do like if you do libpod /containers. Let's do this. Let's do info instead. And apparently didn't like that. I don't know why. What's that? -s. Let's get rid of that. I don't know what that is. And that didn't help.
Silence. S is for silence. It won't give you the progress bar.
Oh yeah. Okay. There we go. So that's all that is. I wonder why that's not working.
It says parse error, invalid numerical literal line 4 line 1 column 4, which would be.
I don't know what that is. It's just not found. So it's not. Oh, it's not JavaScript. I think is why. That's interesting. I thought libpod. Well, here, let's go look at the API documentation. So where's it at? Let's go to libpod. Actually, here, this is a good one. Let's try this because I know this should work. Images. I think images. Read documentation.
We read docs all the time on this channel. It's amazing.
I know. Huh? Why is that not working?
It's the same error though every time. That's weird.
Yeah, it's saying not found, but that's a lie.
Wait, is it because you're trying to find the?
Oh, I think maybe I have to do this. V
is
0.0/ There we go.
Okay.
Scott, you need to be a better person. All right, so there it is. So if you go to this endpoint, v2.0, which is the API, and then you go to libpod, the path libpod, all of these things are here. So like info and images and containers. So go to containers. I think you might have to do JSON.
Yeah.
No, there's none running, so it's not doing
that. Oh, but, well, that'll
you
make
go to
sense.
info. If you go to info, boom, it'll give you info. This is Podman compatible. So like the Podman API is not identical to Docker. That's what people need to understand. So like if you go to this pathed version, all the same things that are in Docker, you'll find like exec and containers, but then you'll also find like pods, so like I could do pods in there. You couldn't do obviously pods on, let's do this. Should be nothing. Let's do this. Maybe you have to do JSON. Yeah, null. So nothing. Null. Obviously, we don't have any pods running, but you would not be able to do. You would not do pods on the Docker API, right? Like on the root path. This is supposed to be Docker compatible, and there it fails because there's no pods endpoint, function or method or whatever they call it. Does that make sense?
Yeah.
There's certain things that are only the root. You can think of the root here as basically Docker compatible, and then think of this as Docker compatible, and then think of /libpod, this path, as all the extended stuff. That's the Podman specific version of the API.
Cool.
And actually you could do one dot. We tell people to connect to one dot, 1.24 or whatever, like,
Whatever their version is. Yeah.
Yeah, whatever their version is. And then,
Yeah.
whatever. But yeah, so
That's
that's
awesome.
kind of that. But yeah, so Podman, we got good stuff going on the podman.io and then docs.podman.io. We added a new tutorials. We actually moved to tutorials, and then we actually have an introduction that's pretty good. That kind of walks through like why you would do containers and how you would do them, and
Right.
it's pretty good.
Yeah, that's awesome. No, this whole session has been fascinating, both in the sense that I've learned so much about containers and that I have no idea where an echo is coming from. So
I hate echoes.
well, it's delayed too, so it's like, where is it coming? It sounds like it's behind me, but it's not. It's actually in my headphones. Anyways, so folks can follow you, Father Linux, on Twitter. They can ping you.
DM me there. That's fine too.
Yeah, DM you there. Your DMs are open, I guess.
Yeah.
Okay.
Or S McCarty at Red Hat. Yeah.
Yeah, there you go. S McCarty at Red Hat.
Yeah.
So yeah, thanks, Scott. Appreciate you joining today. Appreciate you teaching us so much fun stuff about containers and all the underlying things of Podman. And next time, I want you to come on and actually have me running a bunch of pods.
Yeah.
It's like some fully orchestrated service kind of provider kind of thing, right? Like a group of pods.
Like, yeah, typically I'll do the demo of I'll show like how to fire up a pod locally, then I'll export the Kubernetes YAML, then I'll run it in OpenShift. And so like I show you how and then I'll show you how you can export. In fact, in our docs in 8.3, we're going to have this as an example to show people how to move back and forth between OpenShift and Podman. So like if they just have something running locally on their system, they can just use Podman. And then if they want to move into OpenShift, they can go back and forth. So it's cool.
That'd be dope. Okay, cool.
Yeah, we're adding that to our docs in RHEL 8.3.
Very cool. Okay. Yeah, I'm gonna need me some of that in my life because that I could definitely see that as a regularly routine way of me testing stuff. Like just it's like hacking stuff on the fly locally, generate, off it goes. Let's run another scale. Yeah.
Yeah, it's actually ridiculously easy. Podman pod run -it. I think you can do this. UBI8 bash. Let's do that, or let's do ID. I think you can do it this way. Maybe I gotta do a podman pod create. I forgot. I think if I don't tell it a name, yep, there we go. Give that name, and then I think we do. I think you do --pod if I remember correctly. Let's see. No, I can't remember how to do it. Podman pod. Yeah, but it's not hard to, or it's in Podman run.
Yeah.
Podman run, but it's pretty easy. You just do. Where's the pod at? I thought it was --pod, but maybe it's like --add. I have it in my history somewhere. History grep pod.
Yeah,
but it's pretty ridiculously easy. You basically, it's like 2 commands, and then you basically do a I forgot. It's gonna be like every time I've ever typed the word pod.
Yeah. I was wondering, like, what are you trying to get to?
What am I even thinking there? Right? Yeah, well. But yeah, in a nutshell, you basically create a pod, add a process to a pod,
and you just keep adding on, right?
Yeah, you just keep adding on, and then you basically do a generate.
Nice.
Okay. Generate. It's in there. Maybe it's not. It's in my RHEL box. I think that's the problem.
Oh well, see, you do all your work on your RHEL box. You're supposed to be doing it on your bastardized Fedora VMs.
I know, the ones that I just slam it on ruthless too. Yeah, see, and then you run this podman generate kube 682. Yeah, so like I'd have to go through my history.
That was a while ago. Yeah.
Yeah, I'm guessing that was a while. Dude, I keep 200,000 lines of history.
Holy smokes.
Yeah, I usually like just 682. Let's see. So I don't have it in there. I thought I would have. Oh well. I would have thought I would have had the pod stuff in there. Yeah, I can't remember exactly. Sadly, I don't run pods that often locally. I mostly run individual containers.
Right. Same here.
I don't really have a lot of reasons to run pods locally, although there are valid reasons. Like there's times when you want to run 2 different, like you want to have a different container image, but you want them to be able to talk to each other over a socket or things like that. Like there's definitely reasons, but I'll be honest with you, I'm a hacker. I usually just put it in the same container. I just don't see the reason in putting them in different containers. Like, it's just, there's no point to me. If you're going to put them in the same pod anyway, why? Like, why does it matter?
Yeah. Okay, cool. Well, thanks, Scott. I appreciate you coming on. Enjoy the rest of your afternoon, or day, I should say. And yeah, join us tomorrow at 10 a.m. for container management and CRU details. CRU.
Oh, nice.
Or IU. That'll be with
Adrian, maybe?
Adrian. Yeah, Adrian Reber. Or Reber, however you say his last name, I forget. And then we will be doing a tour de force of advanced cluster management. From 11 a.m. to 2 p.m. We are doing nonstop ACM. 3 hours of Red Hat advanced cluster management for you with the one and only Jimmy Alvarez, the only technical marketing manager on the advanced cluster management team. So he's been quite difficult to get a hold of. So that's why it's a 3-hour session starting at 11. Yeah. And I will see y'all out there. Please follow the channel. We are trying to get to 1,000 followers on Twitch by the end of the month. That's tomorrow. So we're at like 940 something right now. 950 something, I think, was the last count. So we're very close. Hit the little heart button on the Twitch channel, y'all. It's like my heart bursting for you when you click it. It's very nice. Thank you. All right, everybody. Have a good afternoon. I will see y'all tomorrow.
All right. Cool.